Steady state exercise. Steady state exercise is when the body is working at a steady state. This means that the lactic acid removal is occurring at the same pace as the lactic acid being produced. An example for steady state exercise will be jogging outdoors or on a treadmill, pedaling an exercise without change of resistance settings or pedaling speeds, or aerobic dancing that uses most of the same rhythm throughout the class. Cardiovascular system. The heart rate will start to increase as you do a steady state exercise. This is because your body will need more blood pumping around your body for your muscles to stretch easier and more oxygen going around with the blood. Stroke volume. When you start an exercise, there is an increase in venous return. There will be a greater amount of blood supply to the heart, which this allows the cardiac muscles to stretch with no tear or injury. This is also known as the Starling's law. Thermoregulation. Our body's normal temperature is 37 degrees Celsius, and if it lowers or increases by even 1 degree Celsius, it will affect the whole body. Heat gets lost by the sweating. Sweating starts to evaporate and cools the skin down. As we start to exercise, roughly 15 to 25% of cardiac output is gone to the skin. As we start to exercise, roughly 15 to 25% of the cardiac output is gone to the skin. The body is too hot, vasodilation and vasoconstriction takes action in the cardiovascular system. This is because when you're too hot, vasodilation will go towards the surface, which is the skin, to keep you cool, and the vasoconstriction will go towards the center of the surface. Vasoconstriction will go towards the center of the surface to keep all the major organs warm, because all the vasodilation, all the vessels will go to the surface at that point, whereas it will leave all the organs with no blood. As stroke volume increases, it will stay the same after a certain time, because it will eventually reach to the maximum level that it can go to. The heart rate will start to increase, and when it starts to increase, it will get to the highest demand possible, which cannot go above the demand, so therefore it will steady out after a certain time. Changes in Starling's law happen when there is more blood going into the heart, which therefore gets the heart to stretch even more. These changes occur in the cardiovascular system because our muscles need more oxygen in our body. So therefore, it needs to get increased. These changes occur in the cardiovascular system because our body needs more oxygen in our body, in our muscles. So therefore, the amount of blood pumped in the body needs to get increased in one way, which therefore gets the muscles and the lungs to work even harder. The respiratory system. Our bodies need more oxygen as we start to do more exercise. We therefore start to breathe out more carbon dioxide. Oxygen dissociation curve. The temperature has an effect on the curve, but this is only a slight effect. This will shift to the right as the temperature will increase, and it will shift to the left as the temperature will decrease, but it's only a slight change. The breathing rate will also change. The breathing rate will increase as we do more exercise. This is because our body will need more oxygen. When it starts to increase, it will then stay the same as doing a steady state exercise. Within the respiratory system, the tidal volume will also change. Just like stroke volume, the tidal volume increases because your body needs more oxygen, so the depth of each breath increases to gain more oxygen in the body and in the muscles. When tidal volume and breathing rate reaches to its maximum, it would then steady out. This is because they wouldn't be able to go over the limit that they already have. With the oxygen dissociation curve, the temperature has an effect on the curve. This is such as if it increases, the curve will shift to the left, whereas if it decreases, it will shift to the right. And the reason why it increases is because the muscles contract more of the blood towards itself, because it warms up, it gets more hotter. However, if it decreases, it's because your body is slightly more cooler than your muscles, and that's normally happens near the center of the body, such as the lungs. These changes benefit the body by taking oxygen from the lungs to the body. This also takes out the carbon dioxide from the body. Tidal volume and breathing rate increases because it tries to take in the most amount of oxygen possible for the muscles to react, for the muscles and for the body itself. The changes in dissociation curves benefits the body because as it shifts to the either left or right, it takes even more oxygen inside and takes out more of the carbon dioxide, which benefits the whole body itself. The neuromuscular system. Pliability. When the muscles warm up, the muscle becomes more pliable. This enables the muscle to become more stretchy without tearing them. When the muscles warm up, the rate of the nervous impulses increase. The speed of the transmission will start to increase too.
He just thought this is coming out.
An example for pliability will be when a goalkeeper is training before a football match. This gets the player to avoid any kind of injury during the game. It also gets the muscles to stretch out even more. The speed of transmissions improves the reaction time. This improves by getting the nerves to work even quicker around the body, send signals around the body and to the main organs. The energy system. This system is responsible for producing most of the energy supplied to the body. The aerobic glycolysis. The glucose is broken down as there is still oxygen existing. It's now broken down into pyruvate. This is because the oxygen is still present. This will now enter the series of reactions. The Krebs cycle. The pyruvate bonds with the coenzyme to form an acetyl CoA to produce ATP, hydrogen, and carbon dioxide. The mitochondria. This all takes place inside the mitochondria. The folds on its surface gives more surface area for the energy production to take place. The folds are called cristae. In energy system, there are 38 ATPs produced in total. 2 of them are from the anaerobic glycolysis, 2 of them are from the Krebs cycle, and the rest 34 are from the aerobic glycolysis. The anaerobic glycolysis is a process which breaks down the glucose without using oxygen. Just like aerobic glycolysis, it breaks down glucose with oxygen. It then produces energy for the cells. When glucose is broken down with oxygen, it builds up lactic acid. But on the other hand, this then leads to a lactic acidosis, which decreases in the pH level of blood. The aerobic system. The aerobic system is responsible for producing most of the energy system supply to the body. The system is slightly slow, but is highly productive. Aerobic glycolysis. Aerobic glycolysis breaks down glucose into presence of oxygen. This then gets broken down into pyruvate. This is where pyruvate combines with acetyl coenzyme A. This produces ATP, hydrogen, and carbon dioxide. The electron transport chain. Hydrogen atoms form a Krebs cycle to enter the chain to form more ATP. This all takes place in the mitochondria. The cristae, which is shown here, increases the surface area of the structure. This increases the amount of energy produced each time, which therefore increases the energy production.